I know that you guys are pumped up to start graphing the exponential and log graphs using our transformations. Holy hot dog, this is so exciting. Let's get going. So transformations are some of my favorite things, so I know you guys will enjoy it just as much as I have. Okay, so I have the two standard forms up here just so we can reference them as we need it, and we know exactly where the A, B, H, and K values are in the problem. Okay, so the first one says to graph the functions, state the transformations, sorry that says transformations, I ran out of room, and state the equation of the asymptote for the final graph. Okay, so we can't forget about the asymptote. Okay, so I'm going to make a little note of it at the bottom so I don't forget about it. Okay, so in this problem, this is our final equation. Okay, so first of all, I need to decide, is this a logarithm graph or an exponential graph? So I know which one to reference when I'm trying to decide what the transformation is. Okay, so since first of all, I don't even see the word logarithm, so I know it can't be logarithm. Okay, so we're going to ignore logarithm transformations. Okay, now, since this thing has an exponent, I know it's an exponential. So when we're figuring out what these different values are, we're going to reference the exponential piece. Okay? Alrighty, so first of all, we start with our parent function. Okay, which the parent function is the most basic form of the graph. And the parent function always just involves the base of the exponential and the exponent of x. That's it. So our parent function has the base and the exponent of x. We're not going to add anything else to the exponent. Okay, so let's think about the base is the number right beside our exponent. So here's my exponent. So the number attached to that is my 1/2. Okay, so in my parent function, okay, I'm going to write it right here. We're going to have y equals the base of the exponential, which is the 1/2. And all we're going to do is write the exponent of x. Okay, so this is our parent function. It's the most simplest form of our exponential function. Okay, so we're going to come up with a few points for our parent function. Okay, so remember when we graph exponentials, we always use these nifty x values. Okay, which beside it, I've written what we do to get the y values, so we're not confused. Okay, so again, 1/2 to the x is my parent function. So at -1, we flip the base, or find the reciprocal of it. So if we flip 1/2, 1/2 flipped will turn into 2/1. Okay, so it'll be -1, 2/1, which is the same as 2, so I'm just going to write a 2. Okay, at 0, it's always just 1, so I'm going to write 1. And at 1, we write the c value. So the c value is the base, and the base is a 1/2. Okay, so we're going to ignore this part of our chart. This is the part we add on later when we start dealing with A or B values, but we'll talk about that later. Okay, so I'm going to start by graphing these points. Now, don't forget our asymptote equation in our parent function. Don't forget. So I'll write our parent function asymptote equation. Okay, the asymptote for exponentials is always the x-axis. Okay, which if you remember, the x-axis equation is the equation y equals 0. Okay, so I'm going to graph my parent function. Okay, I'm going to graph it in a slightly lighter colored purple so you can kind of see it on my graph. Okay, first though, I'm going to graph my asymptote. So remember, our graph cannot cross the x-axis. So I'm going to draw that bad boy in. Okay, and then I'm going to plot these x's and these y's. So my first point is at -1, 2. So -1, 2. My next point is at 0, 1. And my last point is at 1/2. So I'm going to go 1 and then up a smidge for the half. Okay, so when we draw this, you guys, we don't want to cross the horizontal asymptote, so be careful. Be really careful, get really, really close, but don't touch. Ah. All right, and then this one's going to go up. Okay, so this is my parent function graph. Yay! Okay, so this is my parent function. Okay, after you get the parent function graph, whenever we graph transformations, our goal is to tackle the A value first. Okay, the A or the B value, actually. Okay, what's in the problem, if you see here, the A value is the number in front of the base, or the number right after the equal sign. Okay, so it's the number right in front of the base, and the B is the number in front of the X in the exponent. So let's see what we have in our problem. We must tackle the a or the b first. Okay, I totally have a number in front of my base. Okay, so I know that this is going to be my a values, the number right in front of my base. Okay, in my exponent, I don't have anything multiplying to my x. Now, I do have something adding or subtracting, but that's not our b value, so we'll deal with that later. So we must conquer the a or the b value, which in this case, we only have an a value. And our a value is the -2. Okay, so my new equation, we always add on to our previous equation, which my previous equation is y equals 1/2 to the x. Okay, I'm just going to add my a value, which is -2, onto my parent function. So it's going to look just like that. Y equals my new a value, -2, times my parent function, which is 1/2 to the x. So that is my current, most updated equation. Y equals -2, my a value, times 1/2 to the x. Holy hot dog, you guys. Okay, now if you remember, when we deal with a values, okay, we are going to be graphing these original x's. Okay, but our y values are going to change. So let's think about this. Okay, so originally my y values were 1/2 to the x power, but now they are -2 times 1/2 to the x power. Okay, so guess what we're going to do with all of our 1/2 to the x power points? Holy hot dog, you guys are so smart. We're going to multiply them by -2. Guys, so we're going to take our previous y values and multiply them all by -2. Okay, I'm going to start by writing -2 in all these so I don't forget to multiply. And we're going to multiply them to our previous y values, which are 2, 1, and 1/2. Okay, so when we graph, we'll be graphing these x's and these y's, whatever we end up getting after we multiply. Okay, let's see what happens. So -2 times -2 times 2 is -4. Okay, so the first point I'm going to plot is at -1, -4. So I'm just going to write them here. If you want to make a new table, you can. So at -1, we're going to plot -4. Okay, at 0. Okay, we're going to be plotting -2 times 1, which is -2. So we're going to plot -2. Okay, and at 1, we're going to be plotting -2 times 1/2, or half of -2, which half of -2, or -2 divided by 2, is -1. Yay! Okay, so these are the new points we're going to plot for our a value. And since I know the a value is negative and a 2, we can already predict what the graph's going to do before we graph it. So why don't we predict, since we're super awesome fortune tellers and we can look into the future and see what's going to happen. Okay, so the negative a value, since my a value is negative, so the a value is negative. Okay, what that means, remember, a values deal with everything that's vertical, and negative means it's going to reflect. And if we reflect in a vertical motion, we will be crossing the x-axis. So this will reflect over the x-axis. Okay, also our a value, okay, if we ignore the negative, the 2 value is greater than 1. Okay, when our a value is greater than 1, if you remember, this is a vertical stretch. Okay, so the graph's going to stretch up vertically and get skinnier. So this is a vertical stretch by a factor of 2. Okay, vertical stretch by a factor of 2, which just means the graph will get skinnier or more narrow, however you want to word it. Okay, so the proper way is say it vertically stretches and it's going to stretch up 2 times the original size it was. Holy hot dog. All right, so let's graph it and see if that happens. So I'm going to graph these points now. So we have a point at -1, -4. So -1, -4. We have a point at 0, -2. And a point at 1, -1. And guys, our asymptote has not moved. It's still hanging out the x-axis. So when we plot these points, we still do not want to cross the x-axis or bad things will happen to you. The demon cats, first of all, will be coming to you, which that's the best thing that's going to happen to you. So watch out. Okay, so I'm going to connect my points and I'm going to be really careful not to cross the x-axis. Okay, here we go. Alright, so if you see, my graph flipped upside down and it did kind of stretch up a little bit more. Just a smidge, not much. Alrighty, so let's talk about our h value now. Okay, so after we conquer the a or the b value or both, okay, which we only had an a value and we conquered it, so we're good to go. After you do that, it doesn't matter if you conquer the h or the k value next. You get to pick. Okay, so I personally like to do the h value next, so that's what I'm going to do. Okay, which if we look up here, the h value is either added or subtracted in the exponent of my exponential. So if we look at the original, holy hot dog, we have something that is adding or subtracting in the exponent of my exponential. So I'm going to add on this piece to my equation. So currently, we have y equals, I'm going to add on to my previous equation, which is this one right here. So we have -2 times 1/2. But this time my exponent is going to have some more going on. We're going to write x plus 1. Now remember, you guys, the h value. Think of hips. Hips go left or right. Okay, and we have to think the opposite with the h value. Okay, which I'm going to move this over so we're not confused. All right, so our h value is going to be the x plus 1. Okay, and that is telling us, we're tempted to say it's moving right since that's a plus 1. Okay, but actually what it's going to do is move left. Okay, this is going to move left, and this is how many spaces? 1 space. So moves left 1 space. Alright, so we can already predict what's going to happen to the graph, and we know it's going to move left 1 space. So I'm going to go to my most recent graph, which is my pink graph down here, and I'm going to shift over all my points to the left 1 space. Okay, so I'm going to take this point and move it left 1 space. I'm going to take this point and move it left 1 space. And I'm going to take this point and move it left 1 space. Okay? And let's think about it. If our asymptote will move, we have to always ask yourself, is the asymptote going to move in these problems? Okay, my asymptote is going left to right. So if I shift my asymptote left 1 space, it's not really going to move anywhere because these arrows mean it keeps going for forever. So even if I move it to the left 1 space, it's still headed in that direction for forever. So my asymptote is still not going to move, so it's going to remain on the x-axis. So when you guys draw on these points, be careful. We still cannot cross the x-axis. So get really close, but don't touch. There we go. Yeah, so my pink graph has shifted to the right 1 space. Cool, right? All right, and the last thing. So we've dealt with the -2, the plus 1, and now we got to deal with the 3. So we have to ask ourselves, is the 3 an A, a B, an H, or a K? Oh man, you guys are too cool for school. Okay, so the 3 is going to be the K value. You guys are totally right. Okay, so the 3 is the K value, so we have a plus 3. Okay, in my final equation, so I'm going to add on to my previous equation, I'm going to add on the last piece, which is the plus 3. So we have y equals -2 times 1/2 to the x plus 1, and then plus my 3. All right, and the plus 3, remember the k value, do what you think it's going to do. You don't think the opposite. And remember k, think kangaroo, go up or down. Okay, so the plus 3 is going to go up 3. So the k value is plus 3, which means it goes up 3 spaces. Yay! Okay, so now, before we plot our points, let's think about the asymptote. If I move up 3 spaces, will that raise my horizontal line? Absolutely. Okay, going left or right did nothing to the line, but moving upwards is going to do it. So the first thing we're going to do, okay, if you guys ever have an exponential, okay, you go up or down, the asymptote will move with it. Okay, so first thing, I'm going to move my asymptote line up 3 spaces so I know not to cross it. So we're going to move this line up 1, 2, 3. So now my dashed line is up here. Cool, right? Okay, and now that my asymptote line has moved up 3 spaces, so my asymptote equation, if you want to fill it in, you can. Okay, we're still horizontal, and instead of y being 0, now my y is shifted up 3. So my asymptote is y equals 3. Or, this is where it crosses the y-axis at 3. So when the line's going, bam, it smacks the y-axis at a 3. So it's y equals 3. Either way. Okay, so I'm going to go to my most recent graph, which is my green graph, and I'll move all my points up 3 spaces. So I'm going to move this up 1, 2, 3. Move this one up 1, 2, 3. And move this up 1, 2, 3. Okay, you guys, let's see what happens. Okay, we get really close to our new asymptote and don't touch it. And bam, that would be my final graph. Isn't that cool, you guys? It's like a work of art. You could frame this. And don't forget, you guys, it's very important to name your graph. So my graph is going to be named Nancy. I think that's a great name for my graph. So this is graph Nancy. Holy hot dog, this problem has been a blast, you guys.